Well, Ahmed, thank you for the amazing introduction, and I think that was the first time that my name has ever been said so crisply and so correctly in all my time doing talks, so thanks for that. So yeah, today we have an awesome treat for you guys, I hope. I'm going to be talking about AI at the front lines, and specifically how we used ChatGPT to improve our product Socket to help find open source malware. I think it's a really cool topic because it's one of the first uses of LLMs in a security tool, and it really helped to improve the developer experience of our product. And as you'll see, it's a product that developers use a lot, and so it's a great way to improve it. So quick background on me. So I started out in open source, as Ahmed said, and did a little stint on the Node board for a little while. Then I moved into security, so I got really interested in web security specifically and how to build secure web apps. And then now I'm working on scaling open source security so that every organization, every team, developers and security folks can work together and make secure apps. And so that's kind of where this talk comes from. So real quick, a bit on Socket. So I think Ahmed actually did a pretty good intro on it. So it's a tool that a developer can install on their repository, and it will scan your Python and your JavaScript dependencies, look for security issues, and it's used by a whole bunch of awesome companies. And so yeah, let's talk about the agenda. So we're going to talk about two things. So the first is kind of an overview of the state of open source security, and I'm actually really happy that I get to go after Darcy because he actually laid an amazing groundwork of sort of the state of the package manager ecosystem, which actually contributes quite a lot to the problems we have in security. And I think you did a great job of laying that all out for us, Darcy. And then the second part is, how did we use ChatGPT to improve the developer experience of our Socket tool? And I'm going to go kind of into the details of how we actually deployed this LLM and kind of hopefully some useful tips that you can use if you're playing around with LLMs, ChatGPT, and you're trying to build actually useful production apps that go beyond like the typical sort of just another chat interface that you see in a lot of this stuff today, right? So let's get started. So to start off with, what is the software supply chain? Really, the easiest way to think of this, it's just a set of all the dependencies and the components that make up our software. And this is the Create React app example from yesterday. I like this visualization because it has the physics that kind of makes it even more chaotic when you see it in that form. But really what we're looking at here is just the dependency tree, so everything that gets installed in your node modules folder when you go to install this package. And so that's the supply chain. Now, we're pulling from this enormous registry that is NPM, and we actually just pulled the latest size of it from our replica of NPM, and it's actually incredibly enormous. We have every package stored in an Amazon S3 bucket, and it's 27 terabytes. If you want to have all of NPM, every version of every package ever published since NPM started. So I think it's actually not too bad. You could carry around NPM on hard drives in your backpack if you really want to have it with you. Yeah, so there actually used to be a tool in the early days that would let you download NPM to your laptop, but we've kind of since gone beyond that ability. Not to mention all the spam attacks that have added to the size over the years. But so that's the scale we're dealing with, and we've started to see more supply chain attacks. So I've been publishing NPM packages since 2014, and for those early years, there really wasn't too much. It was kind of the innocent days. I like to think about it as the innocent days. Like we really didn't know what we were doing. We were kind of creating this new, there's this palpable excitement to publishing packages. We were discovering how things should be done. And NPM was actually a completely different type of package manager than came before it. It really did a lot of things right that helped propel its growth. But then in sort of 2018, 2019, we started to see these first kind of intense like ecosystem-wide supply chain attacks and malware attacks. The first one that was the most memorable to me was back in 2018. There was a package called Event Stream that got compromised. Raise your hand if you remember that incident. Okay, so see the NPM folks back there. And so what happened was a maintainer named Dominic Tarr was kind of finished maintaining one of his packages, and someone came along and offered to take over. This happens all the time in open source, and he kindly handed over the keys to that package, to this individual, who proceeded to actually make okay contributions for about a month, updated some dependencies here and there, did typical maintenance work, but then about 30 days later, added a new dependency that contained a backdoor that targeted one specific company. And so what happened was that company depended on this package. It got built into their Electron app, and then their users got attacked. So it was a Bitcoin wallet, and a bunch of their high net worth customers just had their wallets completely drained by this. Yeah, so it was really sneaky. It was really not caught by the community for a little while. I think it was about a week that it was there and sort of in plain sight. No one noticed. It's interesting because we think open source is, the solution to all of our problems. If you just put the code in the open, then we're gonna see these types of things and it'll be caught. And it's true, eventually it will be. But the question is, what's the damage in the meantime? And so in this case, the damage was this got built into this project, and real users were affected. And then there's a whole bunch more here. Just some of the memorable ones for me were some of the ones up here. There was maintainers intentionally adding malware to their own packages. That's kind of been an interesting new trend we're seeing. There's also been, there was a problem in NPM itself where anyone could publish any package. Like anyone could just publish any package at any version if they wanted to. If you just knew the right way to do it, you could just take over any package. And this was sitting there for a while. I don't think it was actually used as far as we know, but yeah, that's not good for confidence in the ecosystem. And then of course there's all sorts of the typical kind of cyber threats that we see, like crypto miners and password stealers and stuff like that. So one question is, why is this happening now? What's changed about open source that's causing this massive increase in attacks? I think it comes down to 3 reasons. So the first is we have a massive increase in the number of third-party dependencies. The way we write software has really changed. We're using a whole bunch more services. It's not just dependencies. It's cloud services. It's no-code APIs. You can't really build an app without calling a whole bunch of different APIs these days. Right? This is just how we do things. So the dependencies go even beyond the open source dependencies. Number of SaaS services in the average company is almost approaching 200 different services, and so it's just it's just a lot of sprawl. And then, as was touched on in the talk yesterday, we have this kind of massive explosion in the number of transitive dependencies, pioneered by NPM, really, because NPM made it so costless to add additional dependencies. In previous ecosystems, it was actually quite a lot of, a little bit more work to publish a package, and it was definitely more work to depend on a package in the sense that you could create problems for your users. If you depended on too many packages, you'd actually create situations where users couldn't even complete an installation because they'd have version 1 of foo and version 2 of foo, and the package manager would say, you can't have version 1, you can't have version 2 in the same project. And so folks tended to avoid dependencies for that reason, and NPM sort of said, nope, don't worry about it. Just install version 1, just install version 2. No problem, we'll figure it out. And so I think that's kind of the reason why this is the way we write software now. And then there's this typical stat we always show: about 90% of code comes from open source packages, and so yeah, we all know this. So yeah, this is the supply chain. This is Webpack actually, and you can see it's also pretty massive. This is just one dependency, right? This is like the amount of code we're dealing with here. And then we have this other visualization I like to show, which is another way to look at the same package. So this is Webpack. Every gray box is a package, and every blue box is a file within that package, and the sizes are all proportional. So you can just see kind of the same tree structure, but now you can see the files, and you can see, each animation is basically peeling away one level of the tree. So you're going to go deeper and deeper into the package and see kind of, and this is just one dependency. So that's the thing. I mean, we're building apps that are composed of hundreds of these packages, and so it's no surprise that we end up with thousands of dependencies in the average application. Because remember, each of these has 79 average dependencies, so that's where we get to those big numbers. And just out of curiosity, I opened up the Discord app, and this is the number of dependencies in the node modules of Discord. And you can verify this for yourself. You can open up the app and see. And then if you pull the commits that are that make up those packages, you end up realizing that you actually depend on almost 400,000 people's work over the years. So in some ways, this is so cool, right? I mean, like, this is the power of open source. It's incredible, right? Like, we're all collaborating and we're building this type of software together. But any one of these folks can affect your app. And so that's the first reason. The second reason we're seeing more attacks is that change happens an order of magnitude faster than it used to. And I think my keynote didn't like that I included 12 of those animations, so I'm going to restart. It doesn't like that. Probably is. Okay. And it doesn't like that I'm one slide away from that slide, so I'm going to try again. All right, we're gonna stay away from that slide. Actually, we're gonna delete that slide. Okay, there we go. Okay, so yeah, we've gone from a world of releasing once a year. Companies used to release their software once a year, maybe twice a year, right? And now we release hundreds of times per day. This is not uncommon at the leading tech companies. So in this world, it's really hard for the security team or for a QA team to be the gatekeeper and to make sure that what we're putting out is actually good. And in the name of like developer experience and making things awesome for developers, which I totally support, we've sort of gone to this world of just pushing to production very, very frequently. There's no time for a QA or a rigorous security review process. And then with bots contributing to this problem and every PR merge leading to another deploy, a developer could update a dependency and pull in new third-party code that no one's looked at, and then deploy it to production maybe a couple hours after the package was published. And so this is kind of the problem. So it raises the question, we're trying to have a good developer experience. We want to help our teams move fast. So how quickly really should we update our dependencies? Should we be using Dependabot? Should we be staying up to date? And it's really it's a trade-off. I think if you go too slow, right, you lead to being exposed to known vulnerabilities, which as we talked about yesterday, some of them are actually important, right? Some of them are real vulnerabilities that can affect you, even though the vast majority are not. So we want to avoid those. If we go too fast, we might be pulling in code that no one's looked at, and like the story I told before, we might be affected by one of these supply chain attacks. So what's a team to do? Well, most teams just never. I mean, that's one answer. Just don't worry about it, right? Yeah, another option is just whenever someone feels like it, maybe we'll get some updates. And this is just hard because we have a lot of expertise required to do these updates. It's not easy, and you can't win. Oftentimes you just create more problems when you update. So it's a hard problem. The third reason why we're seeing a lot of attacks is the cost of attacks has gone down. It's lower than ever before. The reach of specific dependencies is actually so large that you're basically bound to be affected at some point. It's not really a question of if, but when, even if you're not a brand name, right? So this is kind of a difference in the security landscape. So earlier this year, there was this tool from Amazon called the CDK. Maybe you've used this before. When people went to go run that tool, they were greeted with this gibberish output. It includes this nice Zalgo text and a whole bunch of ASCII characters. So what happened here? Well, there was this diff was these lines of code were added to one of the dependencies. It was a colors.js dependency. And if you look closely at this, you can see it's basically an infinite loop. Starts at 666. That's nice. And then it has this .zalgo, which basically takes the text and makes it into that crazy output that you saw there. And then there's Uncle Sam for good measure. And so the impact of this was really far-reaching. This was like one little change, but this dependency had a quarter billion or 2.5 million weekly downloads, and so it affected lots of folks. And this is the maintainer themselves who added this code. So there's actually there's also actual bad actors too. So it's not just the maintainers. Actually, there's actually package hijacks that happen as well. These are some headlines from some of the big ones over the past couple of years. And so why does this happen? So why do packages get hijacked in this way? Well, bunch of reasons. Like one could be the maintainer just chooses a weak password. Someone guesses it, someone finds it, that they used it on another website, is able to get in, deliver their crypto miner and make some money. It could be that, like we mentioned with Event Stream, that someone comes along and offers to help, and it turns out that they're a malicious actor. It could be that a maintainer becomes a malicious actor. They just decide one day they want to be a malicious actor. It actually happens more than you think. And maintainers are overworked. Maintainers are sometimes get bitter about that, and it's not surprising that that happens sometimes. And then there's other times they use their packages to protest for a cause that they believe in, right? This happened with the war in Ukraine. Somebody decided to delete the hard drives of any users who had Russian IP addresses. They did this by replacing every file on their hard drive one at a time with a rose, like flower emoji. So their whole hard drive would just be emojis. So that type of thing happens. And then, of course, maintainers can get malware on their laptops, or maintainers could be good and just accidentally update one of their dependencies, and one of them could do this. So lots of ways. There's also ways that the developer contributes to the problem. So we often copy-paste code that we find on Google or Stack Overflow. This is actually getting even worse with LLMs in some ways, because LLMs, often you'll ask them to write some code for you, and they'll import some dependencies. Those dependencies, you might not have actually looked at them. You might not have even gone to the GitHub or NPM page to check those dependencies out. In some cases, those dependencies might not even exist. They could just be made-up dependencies, which is nice, because then someone can come along and register those dependencies later, and then now you're just running that code. So it's a whole new world with LLMs in that way. You can also typo when you're installing the package. That's common. I do that all the time. I try to hit Control-C really, really fast. I feel like I'm pretty fast on the Control-C, so I probably stopped it early enough, but who knows? You can have tooling configured wrong, so dependency confusion attacks. This is where your tooling will fetch code from NPM when you intended to fetch it from your company's internal NPM instance. And the registry can actually just be compromised, as we talked about. And then there's the new manifest confusion, courtesy of Darcy as well. So, well, now everyone knows about it. So, fair enough. So lots to look out for there. Okay, so let's just focus on one of them. So let's focus on typo squatting, because this is the one I do all the time. Typing npm install really fast, I make a typo, I install the wrong package, right? So these two packages, they're a couple letters off from each other. If you install the correct one, you get a nice package that has 50 million downloads a week. If you typo it, you get a package that has 10 downloads in all time, and the code is total garbage and contains like attacks. So here's an example of literally this package. So TTP error. It looks like a normal HTTP error library, except if you scroll to line 112, you get this nice little shell script that's going to run, where it goes to bit.ly, downloads the code from bit.ly, puts it in a file, makes it executable, and then executes it. Nice, right? So I couldn't figure out what this does, because the bit.ly URL has been taken down, but I guarantee you it's not nice. It's not going to be pleasant, right? So yeah, don't run this command. So this is just the tip of the iceberg. Just wanted to give you a little taste. I'm going to show you stuff that the LLM has actually caught in a sec. But just to give you a sense of the scale, we're monitoring NPM and PyPy, and we've seen about 1,000 attacks in the last 30 days that we've confirmed with humans have looked at those and said those are actually real attacks. So yeah, it's quite a lot. And the thing that's so surprising to me is that so there's been research done on this malware problem, and they've asked the question, how long does it take for this stuff to get caught, right? And they found these extremely staggering numbers. Like, it takes 209 days for malicious packages to be discovered by the community. So the really big one, the really popular ones do get caught pretty fast, but there's this really long tail of stuff that has maybe 10 downloads, 20 downloads, right? That's just sitting there waiting for the unlucky person to typo and to land on that landmine, right? And so it just pollutes the registry. So yeah, I think the funny thing too is npm audit isn't going to catch that, right? Because it has 10 downloads. There's going to be no CVEs. So we're annoying ourselves with all this security tooling, and it doesn't even catch this stuff. Okay, so what can you do, right? Let's try to make this actionable and focus on what we can do about this. So I'm going to try to give some examples of where I see the industry heading and like what the leading teams are doing, and hint, it's going to involve developers being part of the solution, not just the security team mandating a bunch of stuff, but actually developers getting involved. But the first thing is that I just think we should recognize it's too hard to do the right thing today. Like that's the main problem here is even if you care about this, like even if you want to do something about it and you want to go out there and like tackle this problem, like there's not much you can do to really get at the core, short of literally reading every line of code of your dependencies, right? That will solve the problem, but like no one can do that, right? So so we need more visibility into the dependency risk. And I would just sort of summarize the problem as this image right here. So, we get pull requests from our team members that add new dependencies, and this is the UI that we see that tells us about what dependencies have been added, right? I can't see that there's potentially hundreds of transitive dependencies here. I can't see the risks of any of those dependencies. I don't know how many downloads this thing has. I don't know anything about it, right? I just have to make a decision based off of this one line, whether this is safe or not. So it's very misleading, or it's very, not misleading, but it sort of is hiding the true number of dependencies that you're going to get, right? So there's not really enough feedback here for developers to make an informed decision, even if they wanted to, right? And it's debatable whether they want to, but let's assume that they do. So quick show of hands, I want to just go through and ask you kind of how do you evaluate packages when you're deciding which ones to use. So raise your hand if you assess whether the package will get the job done for your purposes. Assume that's everybody. Okay, great. Does it have an open source license? Who checks that? Yeah, if it's on GitHub, it's probably open source, right? Don't worry about it. Okay, does it have good docs? Who checks that? Okay. What about the download count or the GitHub start count? Does that factor in? Okay. Do you look to see if it has recent commits to see if it's maintained? Who does that? Okay. Do you look for tests? Do you check the tests folder? Okay, no one does that. A few people do. Okay. All right. This is the real test. Do you check to see if it has CVEs? I guess NPM checks for you, but you're probably not even looking at it. So okay, so no one checks. Do you check to see if it runs a shell script at install time? What about if it runs any executable files, native code? What about if it talks to the network? Do you know if the package is going to send data to the network? Which domains? Does it read or write files to disk? Anyone? Nobody? Do you see if it reads environment variables and which ones? Nope. Okay. Do you look for obfuscated code, like blobs of code that are just mashed up in there, hidden in there? Nope. What about telemetry? So is it gathering data to send back analytics to the developer? Nope. What about if it contains mutable references? Again, Darcy explained those really well yesterday. So if it contains a reference to an HTTP URL or a Git URL, do you check that? Or what about a loose version range, like a star? Okay, so no one's checking these, right? Okay, this is the problem. Like, I want to check these. I want to just know this, but I can't, right? So this is the problem. Now, why can't I just use npm audit, right? I mean, that's just right there, right? No, so the problem is that these CVEs are just too reactive. They're not going to actually tell us any of this information, and they're not going to catch any supply chain attacks. So what I want to focus on here for a second is kind of the difference between vulnerabilities and supply chain attacks. So with vulns, you have usually some time to fix these things. You can catch them, after they've been found. They might be low impact, and by definition, you're sort of you're reactive to this security researcher out there who found this problem and published this report. You're reacting to it and you're trying to address it. So think about a vulnerability like leaving your window unlocked, right? Someone could come along and open the window and go into your house, but someone might not, right? I mean, it could just be unlocked for a month or a year, and nobody will try the window to see if they can get in, right? You should still fix vulnerabilities, but you generally have some time, right? With a supply chain attack, it's like someone breaking into your house, right? Like you need defenses against that. It's not like something that you can react to after the fact, right? So they're intentionally introduced, and they're never okay to run. It's literally malware. You don't want to run that on your computer or your servers. So here's another analogy. Developer spends their time looking under the light because it's the easy place to look. They're looking for these low severity CVEs, these regular expressions in out of service. Has anyone gotten one of these? Yeah. So meanwhile, all the actual stuff that's bad is just out there, and our tools don't tell us about any of this stuff, right? npm audit doesn't tell you about any of this. The list goes on, right? So yeah, we're spending our time on these things, and meanwhile, all this other stuff is out there. So another way, think about it, is re-regging deck chairs on the Titanic. We're missing the kind of key problem here. So the simplest thing, right? The simplest thing, does a package run an install script? This is trivial to detect. This is something you can just look for in the package JSON. Why doesn't our tooling tell us about it? Almost every single piece of malware, like the vast majority of malware, uses this feature, right? Why doesn't our tooling warn us about it? So what can you do? There's some obvious stuff you can take action on. So you can try to use fewer dependencies, avoid them if you can, vet them carefully, take care about which dependencies you use. Definitely use a lock file if you're not already. Pin your dependencies, don't use stars, and then avoid mutable package references. Don't reference at latest or HTTP or GET URLs, and then spend as much time as you can vetting your dependencies. That's sort of all the obvious stuff that you can do. The last one, that thing is, it just takes time. It takes money. It takes time. So that's kind of the challenge that teams are facing. So should you read every line of your dependencies? So I think a lot of teams are trying to grapple with this question as they recognize the threat of a supply chain attack. They want to do something about it. And the question is, okay, should we just bite the bullet and say we're going to just read all of our code? Some companies actually do this. Famously, I think Google does this, and it's really hard to bring open source into companies that choose a policy like this because it has to be extensively vetted, and it really slows things down. It's really bad for developer experience, and often those companies will be using versions that are multiple major versions out of date because it's too much work to get the new version approved, and then they'll end up basically forking the version, the package to fix things, and then they're just off in their own world, and it's just really bad for developer experience. But it is one option, right? So let's say so most teams are doing the sort of no audit scenario here. So they're just saying whatever, let developers install whatever they want. Let's just go fast. So it has the advantage of being fast, but you're vulnerable to supply chain attacks. If you do a full audit, right, it's going to be very safe, but you're going to need to have a team that does this probably. It's going to be slow. It's going to be expensive. It's going to be a lot of work, right? So most of us are over here on the no audit side. So I would contend developers should not be expected to read every line of code in their dependencies. And so if you take that assumption, then what are we going to do about this problem? Because we need to do something. So I think the key the solution is we need to provide more visibility to developers at the time when they're making the decision about which packages to use. And we need to create feedback loops where they can be involved in the security of their apps and get that feedback as soon as possible. So it's not like a security person coming along like 6 months later saying, hey, you have to fix all these things in your dependencies, right? So we want to give developers this visibility as early as possible with automation. So we want to audit every pull request, and we want to look whenever dependencies are being added or updated, and we want to use modern dependency analysis, so not just like CVE scanning. We want to actually look for risks in the packages, and we want to tell developers about anything that looks dangerous. So usages of dangerous APIs, obfuscated code, basically that whole security checklist that you all kept your hands down for. And then we want to push that information to developers. So that one security-conscious developer on your team that notices that, hey, this package should not be making network requests and it should not be reading these files, we'll be able to do something about it. So that's the first step, right? Just put the information there, right? I like to think about it as nutrition facts for your packages, right? So you can look at the label and you can look at what's in your packages if you want to. At least the information is there, and it's a starting point for a conversation, right? So that's the first part, visibility. Then we want to create positive feedback loops. So we want to enable developers to be secure by default. So ideally, right, developers don't have to think to do the right thing. Make it easy to do the right thing, right? So the easy thing should be the right thing. We want to empower developers to be self-sufficient. We don't want to block them. We don't want tools that fail PRs. And we want to put that information as early as possible in the CLI and in VS Code, in all the different places that the developer works. They call it shift left in the security industry. Basically, shift the information as early as possible, and then we want them to be kind of enticed to be part of the problem, part of the solution, not the problem. They already are part of the problem. No, we want to be part of the solution. So basically, we want to go from this to, and I'm going to show a couple screenshots of Socket now because I think we do a good job of this. We want to go from this to something like this. So this is what a dependency upgrade PR looks like. So Socket will come in and leave a comment. And in this case, we haven't flagged this as being malicious, but we've just noted that, hey, this minor version bump actually contains some new network calls, some new file system calls, and some new environment variables that are being accessed. And if you're curious, you can click those links and see exactly what, jump to the line of code where that's happening and see if it looks interesting to you or not. So we highlight those risks. And then if we do catch something bad, then we want to tell you right away, right? So in the case of malware, we'll just tell you in plain English, like, this is the problem. Like, this is what we caught in this package. And this is the cool part. This is generated by ChatGPT. So this text is actually written by an LLM and actually explains exactly what the bad behavior is. So it's way more actionable than like most security alerts that you get. And then, we want to kind of provide more info earlier in the process. So even just like searching for packages, we should be providing scores. We should be warning people that this particular package is actually going to redirect your website visitors to a random petition URL that the developer wants people to see. And it does it with like a set timeout, and it's like hidden in there, and this thing has like 600,000 weekly downloads. So you want to know this before you choose to use it. You also ideally want to even shift left even further. So like when you actually go to install a package that's a typo, like in this case Reacts, you want to get warned about it. So NPM should probably just do this, right? It should say, hey, this name is similar to other another package that's much more popular, right? React, and we should be given the chance to stop the installation before it proceeds. So this is actually a feature that Socket has that can wrap NPM and just transparently offer you that protection. And then we want to have that information in our editors too, right? So we can be told, when we're depending on mistaken dependencies. A very common one that I've fallen victim to a couple times is who uses browsers list, that package browsers list. Do you know what that is? Basically helps you kind of do backwards compatibility with like older browsers. It was really useful when we still had to support IE 11. But thankfully those days are behind us, but it's still a useful tool. So browsers list is different than browser list. The correct one is browsers list, and I install browser list all the time. And so I find that one is often, a lot of projects will actually have both, because the developer just installs the wrong one and it doesn't work, and then they install the correct one and they just leave the wrong dependency in there. So it's just waiting for, it's like a landmine that's going to go off one day. A nice little treat. And then this is actually an experimental thing we're working on. We have a Chrome extension that's going to put the scores and information directly into the NPM package pages. So you'll be able to see that there's problems with the package before you actually use it. So those are kind of some of our philosophies on like helping the developer get involved in the security process. But now we're going to talk about ChatGPT. So how do we use ChatGPT to actually identify supply chain attacks? So I'm going to show you a demo just so you can get a taste of like what is this actually doing in the product today. So here's just literally a bunch of stuff I've found that was caught in the last couple of weeks. And so these are some literal, these were on NP. Wait, what happened to my video? Oh, it's I got to change to. There we go. Okay. Yeah, so this is a package that was, looks like this one has been removed from NPM. It's malware, but you can see this nice little line here that will curl something from this get update.php URL, and then it runs it as a Perl script. So this is malware. So our ChatGPT integration basically found that and then wrote this description here. It says the script is downloading a Perl script from a remote location and then executing it. This behavior is highly suspicious and could indicate a malicious attack on the system. So there we go. So it caught that within minutes of the package being published, and then could show that to the developer. I can go through a couple more here just to give you a taste of kind of the things that it's capable of understanding, because I think it's very impressive. So here's one where it's downloading this like app.exe from an IP address. Obviously, this looks super sketch. I hope you would investigate this if you saw this in any code you're using. So this got caught. Let's keep going. Here's another one. So this one is trying to hide it a little bit more. It's using a function called check SVN, trying to make it seem like it's not just going to own you. They registered the domain npmjscloud.com, so in case you have like a firewall alert pop up, you'll be like, oh, that seems legit. It's not legit. Here's one where data is being stolen from somebody, and it's using it's first getting this request to an internal like GCP server to pull some credentials, and then it fires its credentials off with curl. So this relies on this package being executed in a particular environment where there's this service available where you can just pull credentials from it. Here's another example. This one is just stealing the Etsy password file and sending it to this IP address. Here's this one you see a lot of on NPM. This is just like a pretty standard, let's just take all the information and send it away. This one is going, this is also stealing the .ssh, contents of the .ssh folder. And they try to hide that with string concatenation. Yeah, and then the other thing that's interesting about this one is it also uses, it sends the data as DNS subdomains, and it does like a DNS request. So if you have like a firewall that looks for HTTP requests, it's going to miss this. It's going to appear as a DNS lookup that just happened on the system. And here's one where again Etsy password is being stolen. Here's one where this one's interesting. So this one is it's adding a listener on a form on the submit button, and when the submit button is pressed, it will use this WebSocket and it will steal the username and password out of the form and fire it off to this URL. This might be, based on the name contests here, I think this might be like some student playing around, but still. Here's one that's a reverse shell. Who knows what a reverse shell is? So a reverse shell is basically when someone creates a tunnel between their computer and your computer, and then whatever data they send over that tunnel just gets piped directly into your terminal and just run. So you can see here, it's opening up a shell, and then it's saying, connect to this IP address on port 4444, and then whatever data that just comes back over there, just put that into bash. Just run that, and so it gives them basically remote control over your computer. I can keep going. Maybe I'll just show one more example from the obfuscation section. So it can even detect obfuscation, and it writes really nice summaries. So here it'll say, the code is obfuscated, making it difficult to determine its purpose. However, it appears to be sending the user's environment variables and current working directory to an external server. You can look at the code, and it actually, that is what it's doing, even though it's quite hidden there. You can see it's using HTTPS to send it off, and then it's getting the environment variables from somewhere. There it is, process.env user. So it doesn't get fooled by obfuscated code, and it even gets. There's even more crazy examples of stuff like this, right? So this has definitely been put through some tool to make this code unreadable, and it also catches that. So basically, let's talk about what's going on here. So this is basically the architecture, and this is like a real-world deployment of this. We're running this on like a lot of NPM packages, and so the way to look at this is basically we follow the NPM change feed. So every time a new package is published, that gets sent out, and then we put it through a layer of static code analysis to look for issues in the code, and then we do that as a kind of a pre-filtering step before sending it into the large language model. I'll get to why we do that in a second, because I think it's very interesting. And then the large language model makes the determination based on its suspicion level, whether it wants to block the package or just mark it as suspicious or allow it through. And then if anything gets marked as suspicious, then it goes to human review, the human can determine whether it's good or not. So what are the challenges with deploying LLMs? The number one challenge is cost. They're very expensive. So back of the envelope, the cost to analyze all of NPM, 27 terabytes of packages, about 4 characters in the English language make up a token, and token is what you're billed on with OpenAI. 3 cents per 1,000 input tokens. You're going to spend $200 million just to pass the data into the model. Then there's 6 cents per 1,000 tokens on the output. So you're going to pay again when the data comes out. So this completely takes this approach off the table. We cannot just ask the AI about every package, right? So we need to do something smarter than that. So yeah, I estimated about $1 billion if you wanted to just put all of NPM into GPT-4. So we don't have that much funding. So and I don't think this is a good use. I don't want send this much money to Sam Altman. So, all right. So can we just run an open source model, right? That was something we considered. Like maybe we should just take an open source approach here. There's actually a lot of different models out there. Some open source, some not. The most important thing when you're building an application that's trying to actually, again, not just a silly chat, back and forth kind of thing, but something that's actually making determinations about things and doing inference, is that you need to have models, like a big model size, right? So some of these open source models are interesting, but they're just too small and they don't really work for these advanced use cases today. So I think it's exciting, but it's a little too early at this point to actually use them on stuff like this. So what we have to do is we have to use the cloud models. We have to probably go with OpenAI, right? But we need to find ways to reduce the amount of AI work that we do. So we do this first pass using traditional methods like static analysis to figure out whether packages are clearly safe, and then we eliminate those. And then we use static analysis to look for risk signals. So what is the package doing? And if there's enough suspicious things going on there, then we can go ahead and ask the AI. So we call that kind of idea priors, right? And so yeah, this is kind of where you see this step here where we basically say, are the priors met? And if they're not met, then we just approve the package, because that means it's safe and we can bypass the LLM and get a big cost savings there. The next thing you want to do is you want to memoize to reduce repeated work. So never ever run the same AI prompt twice. If you've run it once, save it in a database somewhere, right? Just don't waste money running the same prompt twice. You're just wasting time and money. So use memoization everywhere, cache results as long as you can. And as a side note, this is actually an advantage of centralization in this model, because when you build a service that does this for your users, you actually are providing them the service of caching these results and amortizing the cost across all your users. So you get economies of scale by basically doing this in one place instead of having it be done by every single one of your users over and over again, paying that expense. So you want to memoize. Then when it comes to prompting, so how do you actually prompt in a way that's going to let you use LLMs for this type of analysis? So there's two main things we do. So the first is called chain of thought prompting, this is pretty standard actually. A lot of people do this, but basically the way OpenAI describes it is GPTs make reasoning errors when you ask them to give you an answer right away. And so what you want to do is get them to kind of think through the steps one at a time and kind of lay out their reasoning as they go, and that will get them the correct answer much more reliably, right? The next thing you can do is use inner monologue prompting. So that's basically asking the model to kind of do the part where it thinks step for step, but not show it to the user. So it puts it in one section of the output that you can parse out and throw away so that the user only gets the final answer, but you're still forcing the model to think through its steps carefully, right? So you can Google these terms if you want to look up how to actually accomplish this in your prompts, but these will help you a lot as you build apps. And then finally, I would say this last one's been pretty useful for us. So you can, instead of using a more expensive model, you can use kind of like a dumber AI and just ask it multiple times, and then kind of take the average of the answers, and that will kind of save you money too. So here's how that works. So if you have a package that you want to analyze, you can basically ask like 5 lower intelligence AIs to decide if they're malware or not. And then if they all agree that the package is fine, then you approve it. But if there's any doubt, then you ask the smarter, more expensive AI to do its analysis. And so you can kind of save costs this way. So if you run through an example here, if all the lower intelligence AIs agree that the package is fine, then you can just approve the package right away. But if there's any dissent and one of them thinks that it's bad, right, then you want to go ahead and ask the smarter AI who more likely to actually catch something bad. So multi-sampling is very useful. How am I doing on time? Am I way over? Okay, all right. I'll just share a couple more lessons and then we'll wrap up. So. The last thing is, one of the last things is mode collapse. So this is when the models kind of fail to generate, they kind of get stuck generating the same answer over and over again. So I think this is very interesting because these companies want to train their AIs to be kinder and kind of more obedient to what we kind of want them to do. And one unintended outcome of this has been that they kind of become boring and repetitive and give the same answer every time. And they've done this through reinforcement learning. So they've sort of like punished it for not doing this. And we've ended up in a place where you actually kind of can get the same answer coming out over and over again. And so one open question is like, how do you actually use prompting to make the models not do this? And one really easy way to see this mode collapse happening is if you just go to ChatGPT and you just ask it to pick a random number between 1 and 10, it always picks 7. Like, no matter how many times you ask it, it always picks 7. You can just ask it over and over again. And I said this was not a better response. It was the same response. Yeah, it just says 7, no matter how many times you ask. So this is an example of this mode collapse happening. And then you can also ask the model to adopt a persona. So if you tell it you are a security researcher before you ask your question, it just magically is better because it's a security researcher now, so it knows more about security. And it turns out you'd think if you say, hey, you are a JavaScript security researcher, that it would be better at finding JavaScript problems, right? That actually is true, it is. But if you tell it it's a Python security researcher, it gets much worse at finding flaws. And I don't know why. I think the Python community is maybe just worse at security. I'm not sure. And I actually wanted to share a hot take really quick. I think the JavaScript ecosystem is actually really good. As we've dug into Python a bit more at Socket, like we've actually found just so many like bad scary things in the Python world, and I feel like the JavaScript ecosystem gets like treated really harshly for all of the things that are wrong with it, but it's actually pretty good. We have like a single way to declare dependencies. They're easily parsable, and you know the packages all declare their dependencies. In Python, it's just chaos. Like every package is just like running install scripts and doing all kinds of stuff. So yeah. So anyway. I think I'll just go over one more strategy and then we'll conclude. So the last thing to look at is often when you're using these models, you want to get JSON output, and they usually just output text. You can ask them to give you JSON, and you can ask questions and say, please return this in a JSON format. When you do that, though, you'll learn very quickly that it doesn't really follow your instructions all the time. So it'll often add extra keys that aren't supposed to be there. It will delete keys that you were expecting to be there. It'll add extra commas or missing commas, or it'll prepend text that says, here is your JSON output, : and then when you parse it, it doesn't parse as JSON. So you have to kind of chop that out. Oftentimes it will get cut off because the answer is too long, and then you'll have to basically parse like an incomplete, like a half of a JSON object. And so there's all kinds of ways it can get screwed up, and you basically have to like parse like a really messy kind of JSON-looking thing, which actually takes a bit of work. But if you do that, then the reward is you get access to this amazing model. So in conclusion, like, does this work? Like, yes, it works. It catches stuff. It's a really hard problem, but it's actually a huge improvement over most traditional code scanning tools. And in practice, we catch a whole bunch of malware with it. So it's been an awesome thing that we worked on. So yeah, so I think that I'm out of time. So thanks so much. Hopefully you learned something, and have a good time at the party afterwards.
Thank you, Feross.